Okay, now we're continuing to work with this example that starts on page 155 of the textbook, where Oris talks about there's a device that supposedly helps light bulbs last longer than their advertised length of 2,000 hours. So what I have here in Excel already is the data file of the 10 light bulbs. Again, light bulb number 1 lasts 2,023 hours. Light bulb number 4 lasts 2,236 hours. Light bulb number 8 lasts 1,942 hours. So for each light bulb, we calculate the, how long did the light bulb last before it burned out. I used Excel to give me my count, my average life, 2,090 hours. We've seen that twice before, once in the 7-step process out of the book and once on the whiteboard, and the standard deviation of 96.25. So now what I'm going to do is take you really through 2 steps. The first thing that I'm going to do is look at the descriptive statistics for this exercise. And I've taken you through descriptive statistics earlier in the semester, but we'll go through the descriptive statistics once again. And then once we've been through the descriptive stats, then we'll actually calculate the one sample difference of means test using Megastat. So let me remind you that to get into Megastat, we first click on add-ins, and we go over to Megastat. And for the descriptive stats, lo and behold, we go to descriptive stats, and we get this screen, and we've got a number of options. So we'll ask the descriptive stats for the mean value, the sample variance, and standard deviation. We'll go ahead and ask for minimum, maximum, and range, and that's probably all that we need to ask for. Okay. Now here it's asking for the input range. I want you to watch what I'm going to do. I'm only going to ask for the input range, and I'll start out with the label for that column, bulb life, and then I just drag down through the 10 light bulbs. Notice I didn't include the descriptive statistics, and I did not include the column for bulb number. I'm only interested in this column here, and that's doing the descriptive statistics on the 10 bulbs. So I just click OK, and lo and behold, we get this output right here. And as you can see, this is consistent with what we've seen elsewhere. Our sample size is 10. The mean life for these 10 light bulbs is 2,090 with a sample standard deviation of 96.25. One thing I do think is interesting to note is it also gives us the minimum and maximum, with the minimum being 1,942 and the maximum 2,236 hours. So getting the descriptive statistics is a trivial exercise. Now what we're going to do, though, is we'll go back to our data. Okay, so here's the 10 light bulbs. This time, instead of descriptive statistics, we're actually going to do an inferential statistics test, what I refer to as the one sample difference of means test. So we go to add-in, we're at add-ins, then we click on Megastat, and now we're going to drag down. This is not quite so obvious, so look closely here. We go to hypothesis tests, and we're going to then drag over to mean versus hypothesized value. Okay, so this mean is going to be the mean that we observe, and we're going to compare our observed mean to the hypothesized value. So we click on that, and it asks for, let me just clear this out so we can start over here. Okay, and the first thing it asks for is the input range. So notice I'm going to use the same input range for this test as I did for my descriptive statistics. Now it asks for the hypothesized mean, and we're going to put in 2,000 hours for the hypothesized mean, because that's what's been advertised. Since we're working with a small sample size here, as I mentioned earlier, since we're working with a small sample size, we're going to ask for the t-test rather than the z-test. We're going to ask for a 95% confidence interval, which is the same thing as setting alpha at equal to 0.05. I am going to click here and have them display the confidence interval. And for our alternative hypothesis, see here where it says not equal? Well, that would be what we call a two-tailed test, which we talked about in, I forget, Chapter 7 or Chapter 8. But in this instance here, if you recall, we set up our alternative hypothesis as mu is greater than 2,000. So we're going to do a one-tail test here with our alternative being mu is greater than the hypothesized value. So now I'll just click on OK, and it will give us our output. And here we have our output. Our hypothesized value is 2,000 hours. Recall that our observed sample mean was 2,090 hours with a standard deviation of about 96.25. Now, if you recall earlier, we said that our observed t-value was 2.97 when we calculated it by hand. Lo and behold, Megastat calculates the t-value at 2.957 as well. You might also recall that the critical t-value from the table on page 377 was 1.833. So since our observed t-value of 2.97 is greater than our critical t-value of 1.833, that tells us to reject the null hypothesis. Consistent with that, our observed p-value of 0.008 is less than our critical p-value of 0.05. And when your observed p-value is less than your critical p-value, that also tells you to go ahead and reject the null hypothesis. Now the last thing I want to show you here is this confidence interval. If you remember in Chapter 8 we talked about interval estimates and confidence intervals, and what this Megastat output shows us is while our observed mean was 2,090 hours, the 95% confidence interval ranges from a low of 2,021 hours to a high of 2,158 hours. So our observed mean of 2,090 hours, that was our point estimate. And then with our margin of error, plus or minus our margin of error, that takes us to a low of 2,021 hours and a high of 2,159 hours. And our observed mean of 2,090 would be halfway in between 2,021 and 2,159. So again, you see in the Megastat output, it gives us what we hypothesized, it gives us what we observed. It also gives us our observed t-value, our observed p-value, as well as the confidence interval, both the lower bound and the upper bound. Thanks.